So, let us have the demonstration regarding the exception handling mechanism in Java, and today's demonstration includes mainly the compile time errors, and then what are the runtime errors are there, and then how exception handling mechanism can be achieved by means of simple try catch block, try with multiple catch, then multiple errors with single catch, and there is another block that can be added with the try catch is called the finally. So, try catch finally block in along with the try catch block, and then throw use in exception handling, and then nested try catch block also. So, let us have the first look about the compile time error. As you know, if you run the program which is not as per the syntax of Java programming language, so the Java compiler report all these things as an error. As you see here in this program, here we can see lot of errors are there, and here we can see in the first statement itself start with error, because Java is a case sensitive. So, capital C in the class declaration keyword is not allowed. So, if we run this program as it is the first execution, so compiler will halt it here, showing this error there. So, we will correct one error at a time. As you see, the compiler will report the class A error here. Now, let us quickly remove this error. Now, we can see there is more error, and public also capital P it is not allowed. So, let us small capital is there, and then again error is there. Let us quick to fix it, right, public, and then system, as we see capital S should be there, and then capital S, and then you see all the statements should be terminated with semicolon. So, as there is no semicolon, so we should make the semicolon here, again put the semicolon as we see. So, Java compiler will compile the program, and whenever it finds an error it will report it, and then until this report is fixed. So, this program will not lead to a successful execution of the program. So, there are few more errors. As we see, any method should not be declared an abstract inside a class method, as you can see here, because it is not an abstract class. So, there is an error, and then there are few more error as we see, those basically compile time error actually. Now, so after knowing this compile time error, let us have the runtime error concept, it is there. Our next illustration to explain the idea about the runtime error. So, let us go to the demonstration 10.2. Here we can declare one class, the name of the class is error, and as we see, this is the one class declaration. Let us follow, let us have the quick look of the class declaration here. Now, here we can see this program is perfectly there is no compilation error, as we have compiled it successfully. However, this program will run, but will not run for all. Now, if we run with this one, we will see it run for all, not for all, but for some. For example, if we run this program with input 1 2, it will run input 1 2 give, it runs correctly. Now, 10 20 30, as we see this program will give an it is 10 30 10 20 30. So, this program also takes this input. Now, what will happen if we give only single output? As we see it also so that single input in this case gives an error. So, this error is basically array index out of bound exception error it is there. Now, again 4.5 and 5, the different error it will basically, it is called the exception. Also we can see the number format exception error it is there. Now, we will see these are not actually errors, they are called exceptions, because in some situation this program not able to handle this, and this is, so program is not, there is no error in the program, rather this program cannot handle all input, that is the cases of exception, that is why they are called exception. Now, Let us see how we can make our program robust using exception handling mechanism. It is there. So, let us have the first program there. As you see this program 10.3, yeah, this program we see there are lot of scope of exception, as we see. For example, in the statement x display yeah. So, okay. So, here we can see in that class demonstration 103 we see a equals to x divided by y. So, there is a scope of an exception to occur, because if y is 0, that means any function is called with 2 arguments, with the second argument is 0, and then again there is a possibility of exception in integer dot parseInt in case suppose if we run this with non-integer parameter passed through the right. Now, okay, anyway, so this program has that it is okay, it is okay. If we compile it, or definitely there is no compile time error. This means program does not have any error there. Yeah. So, if we run it for 2, it is no error, but if we run with say first argument other than 0, then okay, 10 and 0 for example, as you see here 2 inputs, one is 10 and another is 0, because second input if it is 0, it will basically divide by 0 or arithmetic exception. As you see here, arithmetic exception error occurs here. So, this is a case of exception that we can see, and we see this program is therefore not so robust. Now, towards the implementation robust program, we can use simple try catch. So, this is the example to show how the simple try catch can make the program robust. So, here the point of exception where we just enclosed it in the try catch block, and there is another source of exception there, a equals to integer dot parseInt, they are also source of exception there. So, we have just put them in the try catch. Now, this program will run for any input, whatever the input that was not working for the previous case. Now, let us run this program with inputs 10 and 0 again, as it was not working there. In this case, you see it works there, and divide by 0 is reported, and then result 0 is returned this one. Okay. So, this way we can. So, in previous case the program was abnormally terminated rather, but in this case program ran successfully, but exception which occurs it caught and then handle it. Now, next example is basically so how the robust program can be developed. Again the same thing, if we run the different cases, okay, we can skip. Let us go to the 10.6, run the following program, run the program without exception handling mechanism for some input. Let us see have the 10.6 program there. Yeah, 10.6 program, as we see here, this program includes again the exception in many regions here. In the okay, for example, string my string new string I, there is a possibility if I is 0 in null pointer assignment, and then next if my string 0 equals okay, we can write it instead of my string 0, na, you just write args 0, if args 0, right, no, if args 0, okay, that is fine, it will work, okay, if args 0. Now, let us compile this program, and as we see it will work for some input, but not all output, not all inputs. Okay. And again if we run this program, first say Java, input is capital J A V A. So, it basically run this program correctly, and I love Java. Now, let us see, you can see where this program is basically stuck at the point here in the last statement. So, error is there, it will not work for example. Now, what will happen if we run this program without passing any input command line. So, just simply run, yeah, it is also giving error, because array index out of bound error is there. So, we see this program is erroneous. Now, let us implement this with multiple catch block. So, this is an example to illustrate the try with multiple catch. So, all the errors, all the exception those occurs there in the program can be handled using try, or that means try will check if exception if any occurs during runtime, and then corresponding catch will catch all the exception and then handle them with their proper code here. Here very simple code that we have used system println only. Now, here there are point 1 where the error occurs, point 2 also the error occurs, and point 3 also the error occurs here, and we just are in the process of catching this here arithmetic exception, and then if it is there. So, first catch is to catch the arithmetic exception, second catch to null pointer exception, and then the third catch is to array index out of bound exception. So, this way if we run this program again, it will run successfully. Again my string or 0, you can check it arg 0, that is all. Yeah, if statement, yeah, it's okay, fine. Yeah, fine. So, this program is now robust, and whatever the situation happens there in the last case, it was working Java on the input, it is but I love Java, it was not working there. A null pointer exception java dot lang null pointer exception, where it is. Okay, you just do my string whatever it is there. Okay, run this, somehow there is a problem. Yeah, so no compile time error. Yeah, so there is a error because no input. If you do not give input, one error will be there. If we just simply Java, yeah, null pointer java dot lang. Yeah, so it is it was working correctly. There are some bugs there, we have resolved it. Anyway, so now again if we run this program Java without any input, I mean this program without any input, command line output, this also it will catch the exception, and accordingly program will not abnormally terminated. Yeah, array index out of bound, this is why it gives the error. Okay, fine. So, let us have the next one. This is also another example that multiple errors by a single catch. So, this example, yeah, we can see the multiple errors here in the switch statement. Actually, in every switch there is an error is there, and then if we run this program, as we have make the program robust by using single try, but okay, multiple errors are only one try, and then catch is to handle all the catch. Here you can see catch exception E, because of all the irrespective of the type of error, it will catch it. This is the exception E is there, and this program will, okay, if we run it in fact for each switch statement, case statement, it will face an exception, and this exception will caught by the catch statement. Yeah, as we see, so all exceptions those are occur in the 4 case statements are caught in the single catch statement. Now, so there is another block that can be added with the try catch block called the finally. So, here is the next program that we can see, okay, we can see the block with finally. So, all the exception that can be caused by try, here the try statement and then corresponding catch, and then we add it finally statement here, and as you see whatever the exception whether occur or not, this finally statement will be executed, and it will accordingly the code will be code will run and then give the output. Now, let us run this program. As you see, the greetings has the 3. So, this while loop is successful for 3 first 3 loops, I mean 3 iterations 0, 1, 2, but 3 for the 3, because less than 4 means this loop will roll till 3, and for the last one it will report an error, and then we will see the finally we will print this statement accordingly. So, here you can see it will print high statement all the time, but the next if I less than 3 it will do nothing, but it will be if I greater than 3. Okay, as you see, this is the output here, and the last statement finally, whenever I loops is there final. So, here you can see that finally block, if it is added with try catch. So, for every try catch occurrence, this finally will be executed. This is the main use of the final statement, finally statement. Now, our next illustration to highlights the throw clause in a program, and here is basically the demonstration of the throws. As we see, as we have discussed in our theoretical discussion, a throws clause can throw an exception explicitly, and those exceptions then can be caught in the try catch block here. Now, here is a small program segment. As we see, the name of the class is demonstration underscore 1010, and here array is a declaration of size 3, and then try for integer I equals to 0, I less than 4. So, 0, 1, 2, 3, as it is the array size 3, definitely for the first array it is a array index out of bound, exception it will be there. So, for I equals to 0 no exception, I equals to 1, 2 no exception, for I equals to 3 the exception will be there. Now, this exception will be caught in the try block, and then catch will do it, and here actually it will see the different methods those are there in the exception class is invoked here. For example, get cause, then fill stack text, then get localized message, get message, whatever it is there. So, it is basically the implementation of exception class in java.lang throwable package, and according to this we can access this method in our program. So, this catch, whenever it occurs, it catch the array index out of bound exception. For that error, it will basically give the all message trace, and then regarding the complete information about the exception that it occurs there via the different methods in the throwable class. Now, let us run this program, and also it has finally method, and here you can see within this catch block we include the throw statement. It basically throw the exception to the caller. So, this method, if it is called, here the method is basically the name of the method is namely the here method is okay. Okay, so here is no caller of course. So, it will not return anything to any other, but if this method is the try catch block is inside a method which basically throw, then the throw an exception which basically return to the caller here. Okay, fine. So, this is the complete methods are there. If we run it, then we can see how this output it will give for us. So, it is basically showing the exception, as we see for others it will give it. Where is the program compilation? It is there. Yeah. So, Java array index out of bound exception for 3, and it gives all the detailed information about the exception, it is there. So, if you want to scrutinize this program for further details and then the cause and effects and everything, then all those information will be useful. Now, our next example is basically nested try catch example. Nested try catch example, as we have mentioned that a try catch block can be put inside another try catch block. So, it is called the nested here. Now, this is the one program. As you see, this program does not have any error, but when we want to run it, it may leads to some exception. Here this program, if it is run for the 3 different instances, for example, let us run this program and give the 3 instances as we see, and when the exception occurs you will see exactly. So, without try catch, this is the implementation, and run this program first with 1, 2, 3 as an input. Yeah, so this program is successful at this stage. Now, 1 to only 2 input. Yeah, it gives an exception as the array index out of bound exception. Now, again with only single input. Yeah, it is also give an exception, it is also arithmetic exception. Now, no input. Yeah, it is also given error. Yeah, it is also given the error that okay. So, we can see, so this program is vulnerable to 3 inputs, as we have 3 cases, as 3 test data as we have checked it, but it works only for them. So, exception is there. Now, let us see our remedy, how this can be robust, make a robust program using try catch, nested try catch. Now, here if we see the first blocks 42 by A, it is basically arithmetic exception, and if A equals to 1, it is an arithmetic exception. So, it is a very similar kind of exception. So, as it is only one exception, so this can be tried with only one try block. So, this is the outer try block. Now, inside again this is another exception, if A equals to 2, it is basically the exception is called array out of bound exception. So, to take care about this exception, we put another try catch. So, inside this one. So, this is an example of try catch. As you see, the inner try catch caught try for the array index out of bound exception and catch accordingly, whereas the outermost try catch block caught the arithmetic exception here and caused it. So, this is the idea about the nested try catch block. And now, if we run this program and again try with all possible output for which it was not working in the previous case, let us see what will happen. 1 2 3 it is work. Now, Java 1 2 it is 1 2 it is also works, right, it is showing the report there, it basically cached, the exception has been cached. Again 1 it is also see, divide by 0, it is basically the exception has been caught, and then this also by 0 it is caught. So, in this case the program is robust in the sense that in case of exception the program will complete its execution and finally, but without any abnormal termination or any causes of loss of data whatever it is there. So, this is the concept of exception handling. In fact, exception handling is a very important one features in Java programming language scenario, and more practice is required of course. Again I advise you to practice all the example that we have used in this demonstration, so that you can practice of your own, and then this basically hands on practice is required to understand all these things thoroughly, and in case of any doubt and confusion, you are most welcome to feel free to ask us. So, thank you for your attention. Thank you very much and all the best for learning.